So we've talked about the Lustre acquisition, lots to speak about there. We've got these new AI platforms, which I spoke about. Sims is a speaker on all topics. Pete from Wellcome Trust Sanger Institute. We're missing... Where are you? Yeah, Pete's here. Yeah. John, Pete, yeah. Okay, Stefan, Tom. Tom had to leave for another meeting. Stefan's... Okay, great. We're done. So who wants to start the first question? There we go. Let me take the microphone to you.
So thank you, gentlemen. I'll just put this out there because I've got a question from some of my Australian HPC sysadmin colleagues that are Slack channeling me right now. They couldn't make it all the way here, but it's a good opportunity. I don't know if this is a contentious question, but I'll read out what my colleague wrote, which he said, Lustre uses ZFS as a back-end storage solution these days. ZFS RAID Z3 is arguably better and safer than anything else. Will ZFS software RAID continue under DDN? And because DDN have, of course, hardware RAID. So any thoughts or clarifications?
Very good question.
Some ZFS software, right? So, I mean, if they were dumb enough to do it for us, then they might do it again.
Yeah, I mean, a lot of the people we work with have used ZFS in their solutions, so we would expect to continue with both options. Yeah.
Do you want to add anything, Robert?
I mean, the one thing I would add is that there are advantages to both sides. So the SFA has one thing going for it that is unique, which is you can put literally hundreds of devices behind, 400, 800 devices behind a single processing element. So there is an efficiency gain with that. So, again, there are two options here, and we will continue both options. So, as Steve said, we have sold Steve some CFS, and we will continue to do so. But we will also educate you about what the advantages and disadvantages of both sides are, and there are advantages and disadvantages to both sides.
And we have an SFA 12K, and we've prepaid maintenance to DDN on that SFA 12K. So we'll be using it for at least another 2 years.
Until we'll sell you an 18K or...
Well, right.
That's what a lot of us are in Australia interested in here is the 18K part as well.
Yeah.
Some of us just bought 14K. I'm pushing a 12K out to some parts of it over 5 years next year, so I believe maintenance might grow a little bit in cost. But yeah, I think it's interesting for us down under to see what's happening with ZFS particularly because you've got Sequoia running Lustre on ZFS.
Right.
But there's pros and cons, and we would like to evaluate what's best. And an all-native ZFS option is attractive to a number of East Coast HPC companies in Australia.
Yeah. So it'd probably be good for you to go to the BOF on Tuesday, and there'll be a lot of users there. There'll be I could introduce you to a few people who I know running Lustre and ZFS, and of course.
Yeah, great suggestion. Thank you.
So the good news is with the Lustre move to DDN is the agreement that it remains vendor agnostic, hardware agnostic, and that's been core since we started using it over a decade ago. It stayed that way, so you get to choose what you want, you get to try it.
Yeah, I'm interested to see maybe a published bundle on either 14K to delve deeper into the ZFS option. That would be interesting. Horses for courses, but yeah, it's something that's on the horizon.
Any more questions? Let me take the microphone down. Hi, Renato.
Yes. First of all, let me thank you very much for all the exposition, all the talks that you've delivered here. Thank you very much. My name is Renato Micheli. I speak for Laniak from Brazil. So yeah, long trip to get to Frankfurt. Yeah, I'm a little bit jet lagged, so please bear with me. So I have a question that I wanted actually to ask you, mostly for the previous panel session, but please let me know your thoughts. We've been talking very much now, well, especially now for the last 2-3 years about AI and how it interacts with HPC. What are your thoughts in terms of looking from the financial, the economic perspective? Is there an actual new market for AI? Is there new funding coming, or is it being squeezed on the same funding for HPC, and how that impacts the design and the specs for storage now that you have to accommodate AI workflows and workloads along with HPC from the storage perspective?
So I'll take that one. There's absolutely, we talked about in the previous panel, the convergence between HPC and AI. And what we've seen is that the traditional HPC applications for a long time were completely burdened, overwhelmingly so, by checkpoint restart. All of the time that they could spend doing I/O, all of the time that they could think about storage was just doing checkpoint restart. And it was just this horrible problem, and it was getting worse because the memory size with each successive machine get larger and larger, the component counts gets higher and higher, which means the time to failure shrinks, which means that the frequency of checkpoints increases. But now with IME, we've solved the checkpoint problem. The checkpoints are really fast. So what does that mean? It means more funding for AI is going to come from the HPC world. I don't know why you laugh. It's true. Because now because in two ways, okay? One, all of a sudden the scientists who've been producing all of this data now suddenly have time, because they're no longer doing checkpoint, to start doing visualization and analysis on that data. And second of all, the IME platforms allow embedded applications. So you can get decoupled AI from your simulations because the compute produces data which goes into IME. The visualization can run, the analysis can run. So all of a sudden these HPC scientists are realizing that they need to extract insight from the massive data that they create. AI and machine learning are the techniques that they're doing it. And you can see in the US, in the national labs, there's more and more funding, more and more attention coming to AI and machine learning.
I mean, I would add to that we certainly see the emergence of a separate market that's not an HPC market. So we as an HPC company never had much access to web and cloud companies, for example. The web and cloud companies do a lot of AI. So suddenly their whole I/O requirements change. We have organizations that we couldn't sell to a couple of years ago that buy suddenly enormous infrastructures with hundreds of petabytes, literally, essentially for AI. So yes, there is certainly the emergence of a different market. Now, that market also has many individual contributors, scientists who have one system, a couple of nodes with GPUs that do not use large infrastructures yet. So there is a question that I think we are interested in to see how those two sides, the thousands of individual researchers, data scientists who use an application on a workstation or on a single GPU node, and on the other side, the large HPC centers that have infrastructure. So is there going to be a bridge between those two? So what will these future infrastructures look like? So I think that's an interesting area to discuss.
And just an add-up question, perhaps for or to users. Do you see in the foreseeable future specific funding for AI exclusively added up on top of the funding that you already have for grand challenges in HPC?
Yes.
Thank you.
No.
Okay, Ty.
So academia is kind of a very broad church. There's no one size fits all. Some places have really got their cost spending nailed down. And they are really able to kind of get going ahead of other people. You'll see a research area where they get the stuff in fast. And it starts to align more with what you might expect to see from some of the business perspectives. So a lot of their workloads be project-based. So you'll see the funding coming for that project, for those concerns, for those items. And that also helps to alleviate some of the pain on how you manage your costing. Do you do show back? Do you do charge back? All of these things have pros and cons.
So would you not say that AI allows you to get, extract a lot more value out of the data you're getting from microscopes, and that's going to have a positive feedback into the purchase of more?
Exactly. If a project has success in a particular area, you see it being taken up by the people. So you may see some of the budget moving within those project groups going from one area to another, but it'll more be within those areas. So one of the things we're seeing more of are people trying to put together services. The idea is not the tool, it's the service that you get from it. People want something that's really low barrier to entry. It's brought home by some friends visiting a few weeks ago. They brought the 2-year-old with them on a car trip. 5 hours in the back of the car with an iPad. They get out, they start playing Wii with my kids, and the 2-year-old goes up to the TV and thinks it's a touch screen and knocks it all over. That's the barrier to entry. People expect this. They expect there to be a service. The scientists want to perform the blue sky research, but they really don't want to know what's going on behind the curtain. They just want to get their stuff done, right? They are the experts on what comes out of the R analysis later, out of something else later. All the stuff in front of it is just a back end for a service for them. And that's the part that we're seeing. And that's the part of that, the GPU, the AI, the storage. It's got to work seamlessly. It's got to work full stop by the time it comes to them. And the reproducibility, the reliability, and the robustness of the service we provide, that's going to be key to whether or not these things work in the future.
Very well said. Thank you, Pete. Any more questions? Oh, great. I might grab that microphone and send it over this way.
So you spoke about what AI can learn from the old HPC world, and you came by a lot of experience and things you learned over the last 25 years. But how is it the other way? How can HPC learn from that new way of working? What would you think is key for us to adapt to go for a multi-purpose environment that can fit to some certain both worlds?
I can answer that one first. I got an easy answer. I already said it. So HPC went through this life cycle over 10 years of thinking CPUs was everything and forget about data. And now it's kind of flipped. They're very data-centric, and the CPUs are things like just commodity stuff that you use to make your applications run. And I think the AI community, I would say this, but I think they should concentrate less on the GPUs and more on the whole data environment and how to manage that and how to grow that at scale.
I would say also the main way that HPC can learn from AI has to do with the computational models. So HPC simulations for a long time are very, very tightly coupled. And some of that is dictated by the physics involved, but some of that is just because those are the methods that they're used to. And now the AI frameworks, as James says, have evolved, and there's a ton of them that are really useful. But what was the original one that really enabled, I think, the explosion and the emergence of AI? It was MapReduce. And MapReduce is a really fantastic, powerful tool when you can decouple all of these multiple tasks. And that is how I think HPC needs to learn from AI, is that not every problem has to be solved with parallel computing. And by the way, AI needs to learn from HPC that some problems require parallel computing.
Any more answers?
Yeah. So you're absolutely right. Absolutely agree with you. One of the things we put in the presentation earlier is how we've got HPC, cloud computing next to each other. And it's the same sort of idea here. What can each field learn from each other? And the single biggest thing we're seeing now from graduates who are coming through is they want to get back to basics. They want to have very rapid incremental changes to their code. They want to see it now. There is no concentration span here, right? If it's not done in a day, it's too long. So this rapid iteration, this fast cycle, this fast turnover rate is going to be key to success for these guys. And they are the ones driving the research. They're the ones driving the science. They're the ones driving the technology. HPC had a difficult birth, and it's still, in some ways, seeing the results of that, where a lot of the tools are designed for the hardcore geek. That's great if you are that hardcore geek. The scientist coming to use it is probably not very happy with that. And it's tying those things together. So there are, as you say, a large number of tools coming through. We've seen the MapReduce, we saw the dupes. But But the part we also saw with them is they all came with GUIs to help people. If you look at the GPU side of things on the AI, you'll see things like digits out there. That gives them a graphical interface that they can kind of drag and drop the sample on, and you can do stuff and have a play and get an idea very quickly of what works and what doesn't. And it's that rapid iteration cycle, I think, is one of the things that AI is offering HPC a bit of a lesson.
Speed to market and the different tools that run parallel at the same time in different versions. I mean, with the frameworks they're coming out so fast, but sometimes you still want to have the old one while running out with the new one. So the containerization and this secure multi-tenant.
Time to market, reduction of risk. You don't want to wait 2 years and that massive project, it gets there and you didn't expect it to do that when it gets there. All those projects that have failed.
Thanks, everybody. That's a lot. We've got lunch now. Let's thank all these wonderful speakers. And thank you, the audience, for coming here today.